Hey there! This week in class we're going to be learning the difference between ionic compounds and covalent compounds. So I went into my kitchen and I grabbed 3 different compounds. I grabbed water, which is a covalent or a molecular compound. I grabbed sugar, also a molecular compound. And I grabbed salt, which is an ionic compound. Now we're going to go into a lot more detail about what the difference is on the molecular level between an ionic and a covalent or molecular compound. But to start us off, I've constructed a simple circuit to illustrate one of the big differences between ionic and covalent compounds. So if you come a little closer, I'll show you this circuit that I made. So this is 2 D batteries, each 1.5 volts, and they're wired in series to give a total of 3 volts. And then from the negative terminal, I have a black wire coming out that's connected to a little aluminum electrode. And then from the positive terminal, we have a red wire coming out that's also connected to an aluminum electrode. And you can see we have a little light bulb wired in with our batteries. Now the circuit is open, but when I close the circuit by connecting the 2 electrodes, the light bulb turns on. So we can use this to test the conductivity of different materials. Let's test this penny. So we know pennies are made of metal, which conduct electricity. So when we put the 2 electrodes onto the penny, you can see the light bulb lights up. Okay, now let's check the water. So we dip the 2 electrodes into the water, and you can see nothing happens. The light bulb does not light up. The water does not conduct electricity. I'm just going to dry the electrodes off a little bit. Now with the sugar, we can stick the electrodes into the sugar. Same thing, nothing happens. And again, I'm just going to clean the electrodes off really quickly. And then the salt. Okay, same thing, nothing happens, kind of boring. But now what's going to happen if we dissolve the sugar and the salt in water? Alright, so now our salt and sugar are dissolved, and we can test the conductivity of the sugar solution. And we see the light bulb does not light up. And then when we test the conductivity of the salt solution, you can see the light bulb does light up. So why the heck is the salt water solution conducting electricity? Let's take a closer look at the atoms.
The sodium atom, being a metal, has a very loose hold on her outermost electron. Busy jittering around, she does not notice the hungry chlorine atom lurking nearby. He snatches her electron. Sodium, without her electron, has become a positively charged cation. Chlorine is now chloride, a negatively charged anion. Their opposite charges make the 2 ions irresistible to one another. They form an ionic bond. The ionic bond is strong, holding the ions together in a rigid lattice. It seems that nothing can break this bond. Until a deluge. Water molecules surround the 2 ions, shielding their charges and breaking their attraction. The 2 float apart separately in the solution. An electrical voltage is applied to the solution. Sodium is pulled to the negative electrode, and chloride is pulled to the positive electrode. The ions exchange electrons with the electrodes, completing the circuit and creating an electrical current that powers the light bulb.